Hello, fellow STEMinistas, and thank you for joining us here on Facebook and YouTube for our amazing interview with our special friend, Paula Garcia Todd. My name is Andrea Harp, and I am a STEMinista role model. A STEMinista role model is anyone who loves to inspire girls to become the next generation of STEM innovators and scientists. If you don't know, a STEMinista is anyone who's loves science, technology, engineering, and math. It's anyone who's interested in building, experimenting, designing, or learning. The STEMinista project is focused on 4th through 8th grade girls, and we try really hard to provide lots of amazing opportunities for girls right here at the Michigan Science Center or virtually or on our social media pages. Without further ado, I love to invite our special guest and friend of the STEMinista project, Ms. Paula Garcia Todd, to come on and chat with us today. Hi, Paula, how are you?
I'm great. How are you?
I'm doing well. Thank you so much for joining us. Would you take a minute to introduce yourself? Tell us where you're from, where you work, and what was that thing that got you really inspired to start your STEM career?
Yes, I'd love to. Thank you so much for having me. I'm so excited to be here with you tonight. So my name is Paula, and I'm actually originally from Brazil. I moved to the US when I was 9 years old, and I did not speak a word of English, believe it or not.
Wow.
So all of my family is still in South America, except for my parents and my brothers who are here in the US with me. And currently I live in Atlanta. I have gotten a chance to live in a lot of places. I lived in Michigan for 8 years, which I loved, except the winters were really, really cold. I've lived in Pennsylvania. I've lived in New Jersey. I've lived in Chicago. And
Wow.
now I'm really enjoying my time in Atlanta, which has been really fun. And what was that moment that helped me decide that I wanted to be an engineer, which is what I am. I'm a chemical engineer. I actually came from a family of engineers. So my grandfather was an engineer, my father was an engineer, my uncles and both my older brothers were engineers. And so I was lucky to grow up in this environment where nobody ever asked me what I wanted to be when I grew up. Everyone always asked me what kind of engineer I would consider becoming or what kinds of problems I would want to solve. And I decided really early on that I wanted to help sick people feel better. And
Wow.
so I went into chemical engineering knowing that I wanted to work in the pharmaceutical space. And that's where I've spent 18 years of my career, which I've really, really loved.
That's awesome. Thank you so much for sharing that. And for our friends in the audience, if you have questions for Paula, feel free to type them in the chat and we will answer them, or she'll answer them toward the end of our interview. So without further ado, I definitely want to get into some more questions. Paula, can you tell us what are some of your hobbies? What are the things that you do in your spare time? What are you interested in? What are you reading these days? Just tell us a little bit about that.
So I have three wonderful kids and they keep me super busy. So their hobbies end up becoming my hobbies. So when they want to go camping, we go camping, and soccer and volleyball and all the various things that they do. I personally myself, I love to play volleyball. I love to go out for runs. I'm not like a marathon runner, like short runs. And I love music. Being from South America, I love Latin dancing, like salsa dancing,
Very cool.
and things of that nature. Yeah.
That's awesome. I love to dance. I feel like sometimes I don't always know what to do when I'm on the dance floor, but I do my best.
As long as you're having fun, that's all that matters.
Long as you're having fun, absolutely. Well, thank you for sharing that. Can you tell us what it is that you do now?
Sure. So, although I work in pharmaceuticals, people always wonder if I work on the drug discovery stage of pharmaceuticals. And actually, what I do is I work on everything else that goes into a pharmaceutical formulation. So, believe it or not, whenever you take a capsule or a tablet or that liquid medication, there is an active ingredient in there, and that's like the molecule that's that has the therapeutic effect that's going to make you feel better.
Mhm.
But there are a bunch of other products that have to go in there too. So you need coatings and binders and things to kind of ensure that everything is mixed well together. And all of those things outside of the active ingredient are called excipients. And so I've worked on different types of excipients for a really long time. And right now in my role, believe it or not, so I started in chemical engineering. I've done a lot of different types of roles in chemical engineering. I've worked in manufacturing plants, which are like factories, and they're really fun, really big pieces of equipment. Sometimes you get to climb on top of them to see when things go wrong. It's fun. I've worked in labs. I've worked in a lot of different settings, but now I'm actually in a business role. And to me, that's the real beauty of having a STEM background, because although I sit in a business role, I would not be able to do the job that I do without having that chemical engineering background that
For sure.
really helps me to understand how pharmaceutical formulations work, you know? So today, the products that I work on are found in 1 out of every 3 oral solid medicine globally. So
Wow.
that's pretty cool and pretty impactful to know that I'm helping people around the world.
That is really important and really impactful. And I feel like the next time I go in my cabinet to take a medication for a cold or whatever is going on, number one, I'm going to think about you, but I'm also going to think twice about all of the work that it goes into manufacturing and engineering those products. So thank you for all of that work that you're doing. So
Absolutely.
absolutely. So I would love to learn a little bit more about a day in the life of a chemical engineer. So for all of the folks out there that are really interested in that career path, can you tell them some of the things that they might do on a daily basis?
Yeah. So chemical engineering, obviously, because I'm a chemical engineer, I think chemical engineers are awesome. But I do think chemical engineers are very versatile, because at the end of the day, chemistry is absolutely everywhere. Chemistry is needed to make clothes, it's needed to make foods, medicine. Your whole body is made up of chemistry, right? And so chemists and chemical engineers are needed in all kinds of industries. They're needed to make paper products, plastic products. They're needed in the energy space. They're needed to make electronics. Those phones and iPads and computers that we love so much would not work without the help of chemists and chemical engineers. And so having such a variety of different industries that you can touch also means that you have a large variety of types of jobs that you can have. And so, like I said, you could work in a factory setting where you're helping to make large quantities of chemicals that are needed. And when I say chemicals, I mean anything from shampoo to makeup to raw materials that go into making diapers. And I mean, you name it. There's so many things that need to be made in a chemical processing plant. You could also work in a lab environment where every day you're creating new molecules and creating new solutions for different chemical problems that could be solved through chemistry. I personally, because I sit in a business role, my day to day tends to be a lot of phone calls, a lot of meetings, right? But I'm still working and talking to a lot of pharmaceutical companies to understand what are their challenges, what are their problems when they're trying to make these medicines. And then I think through with my technical team of what are the things that we can do to solve all those challenges, and what are the new products that we can bring to market to help solve all those problems that are out there.
That's pretty awesome. Thank you for sharing that. I love always hearing about these different career paths because it definitely shows, how versatile STEM is. All of these skills that we are trying to offer opportunities to our girls to learn and to be exposed to. This is the real world application, and that's what makes all of this so cool and so amazing. So I appreciate you talking a little bit more about the work that you're doing. So I heard that you are an IFTIN ambassador, and I would love to know a little bit more about what that is, and when did you realize that you were just interested in inspiring girls to be the next generation of STEM innovators?
So, I've actually, you asked me about my hobbies, and honestly, one of my biggest hobbies is visiting classrooms and visiting organizations and sometimes blowing things up or making polymers or just getting kids really excited about STEM. And I've been doing that for years. I love it. I'm especially interested in getting more girls into STEM fields because today, less than 20% of engineers like myself are women. And we really need to bring more women into these fields to bring that female perspective to help solve a lot of problems. And so I've been doing that for a long time. So a couple years ago, the American Association for the Advancement of Science, I know it's a really long name, but basically they're a national organization. And they decided to look for 125 female role models across the country to serve for different purposes. So to do interviews or, to tell our stories, to visit classrooms and to do all those things. And so I put my name in the hat. I didn't think I'd get it. And sure enough, they picked me. So I am really honored and thrilled to be an ambassador. Like I mentioned, a lot of really cool things that they do. Some of you may have even seen some of the ambassadors. There's a CBS Saturday morning show called Mission Unstoppable that features some of the ambassadors. And sometime this year, I hope, there will be a really big exhibit of 3D printed statues of all of us, it's amazing. And it will be the largest exhibit or display of female women in one place at one time ever in the United States. And it'll be all STEM women. How incredible is that?
That's so incredible. And when you find out where that's going to be, please share that with us so that we can share that information with our audience. That's so
Absolutely
amazing. I know I don't have a statue, so I'm pretty excited for you.
It is exciting. It's really fun.
Awesome. So tell me, who inspires you? Is there anyone that you look up to as a role model?
So I think people tend to have some like really famous scientist names that they usually give out at this point. But I have to be honest, like I'm really inspired by everyday people that I work with. There are amazing people that work in STEM and they do really impactful work every day. And they're not in history books and they're not, the Einsteins and things like that. And those are the people that inspire me every day. My coworkers, people even like my brothers and my dad, who also are engineers and they're contributing to society that way. Those tend to be my biggest role models and inspirations.
I love that. I love that anyone can be inspiring to the next person. We all can be leaders. We all can be people who are contributing to our communities. No matter what age you are, there's always something that is helpful and meaningful to the people around you. So I love that answer.
Yeah, I agree 100%. And it's funny that it took me to get to the age where I'm an adult to realize that even when you are young, even when you are a student, as the middle schooler, there are elementary school kids that are looking up to you. As a high schooler, there are middle schoolers that are looking up to you. And then when you're in college, high school students are looking up to you. So no matter what stage in life you're in, you can always serve as a mentor, as a role model, as an inspiration to someone who's younger than you.
That's so awesome. Thank you. Thank you again for sharing that. So we do have a question, which actually is really cool because it ties into our very next question. So I'm pretty excited about that. I love when that happens. So if anyone in our audience, which it sounds like there's someone with a 12-year-old daughter who is actually interested in chemical engineering, if there's someone out there, what are some of the things that they should do or should consider when going into chemical engineering? And not just that, there's a comment stating that there's a lot of focus on mechanical engineering or other types of engineering in general. So what's some of the advice for someone who's really interested in pursuing chemical engineering?
Yeah. So when it comes to engineering, there are actually tons of disciplines out there. I think there are like over 20 disciplines. You can do Google searches to learn more about the differences between, a chemical engineer versus a mechanical engineer. Like I said, I'm partial to the chemical engineer because I think it's very applicable, but so are mechanical engineers, to be fair. Mechanical engineers can also work in a broad variety of industries, 100%. Chemical engineering, what I like about it is that there's a lot of math, but it also brings in chemistry. And then in my field, working in pharmaceuticals, there's biology that's brought in too. So it's a nice combination of a lot of different disciplines and sciences. If you're young and you're interested, I would encourage you to do what you're doing today. Talk to engineers, find out more about what it is that they do. So you start to gauge what are the things that you like, what are the things that you don't like, right? I would encourage you to challenge yourself as you're going through school to try that chemistry class and to try that harder math class and to know that it's okay, if you don't do really well on a test or, if something feels hard to you, that's okay because a lot of STEM fields are challenging. And what you just have to remember is that you can stick with it. And a lot of things take time and practice to really develop and fully understand. So don't get too hard on yourself if something in math or chemistry or biology or physics or any of these classes starts to feel hard. Everybody has that moment where something feels hard and you just have to work a little harder. A lot of people think that engineers are just naturally good at math and science, but the reality is everyone has to work at those fields. Everybody does. And it's something that you can learn. It's not something that is necessarily innate for everybody who is an engineer. And so I'd encourage you to read some books about chemistry, and especially as at the age of 12, middle school, going into high school, try some of those harder classes and see what you think of those.
That's really great advice. I appreciate, that feedback, especially from someone who is in the field and doing the job right. You have a really unique perspective on, the path that you took versus maybe the advice you'd give to someone who's pursuing it now. So thank you, Nakia, for that question. I just saw who listed it there. So thank you. And she actually is a mom of one of our STEMinistas. So
Oh, cool.
Shout out to Kayla. So next question, which really ties in nicely to what you were already talking about is what advice would you give to girls who are watching now and pursuing a STEM career? Outside of course, taking those hard classes and finding those connection opportunities like the STEMinista project and other programs that are taking place, throughout our country. What's the best advice that you can really give us all?
So I think what I mentioned earlier tends to be one of the biggest pieces of advice that I usually give out, which is just because something feels hard, it doesn't mean that you weren't meant to do it. So stick with it, and always work hard at the things that you're passionate about and you want to do. But a piece of advice that I think is really applicable to girls in particular is to learn how to form a community. And that's what I love about the STEMinista project, to be honest, because not a lot of girls tend to go into STEM right now. And that's something that we're trying to change, right? So there will be moments where you're sitting in a math class or maybe a physics class, or if you go into college, similarly, some of these engineering classes where there won't be as many girls there as in other classes.
Right.
And girls tend to be very community based and very collaborative in nature. And so when you find a community, maybe it's some girlfriends that have similar interests, or some girlfriends that you can help each other out on with homework and things like that, that tends to lead to a lot of success for girls in particular in STEM. And your community doesn't have to look exactly like you. I'll be honest. I had a lot of guy friends as well that I really got along with, and and we were all very supportive of each other. But finding that support system, however that looks like, however those friendships look like, really, really important as well.
Absolutely. And that's the thing. I mean, of course, I work for the Michigan Science Center, and the STEMinista project is obviously near and dear to my heart, but that's something I love too, as a mom who also has a daughter who's 10, that sense of community that the STEMinista project provides, with the connection to role models and women in STEM who are doing the work and really want to support girls that are coming up, is something that we work really hard to try to provide. So I echo that advice. So audience, as we kind of wrap up here, if there's any other questions that you have for Paula, this is definitely the time to enter it in the chat. But while people are doing that, Paula, can you tell us how we can follow you, how we can stay engaged with you? Because, hey, let's be real. We want to know what's going on in your chemical engineering world. We want to know everything.
Yeah, absolutely. So I'm on Instagram, and you can follow me at Watch Me STEM. I'm also, as you grow older, some people may tell you to consider going into LinkedIn, which is a community where a lot of career people put their information and so forth. If you ever go into LinkedIn, I'm also in there. I'm happy to connect on LinkedIn. You can just find me by my name, Paula Garcia Todd. But for sure, if you want to connect with me, Instagram is probably the best way. And if you have a specific question that you didn't get to ask tonight, please feel free to DM me on Instagram. And I answer all of those questions that I get through direct messages as well. So feel free to reach me that way.
That's pretty cool. Like, I feel like you're a celebrity receiving your questions in your DM. So I think I might have to come up with a question. So doesn't look like there's any questions from our live audience. So with that said, I definitely want to thank everybody for joining us this evening. Of course, thank you, Paula, for joining us for this interview, but more importantly, thank you for all of the really important work that you're doing to connect with girls and to really learn more. Oh, it looks like we do have a question, and it came from our CEO, Mr. Christian Greer. The question is, what are some of the really hard problems that you are trying to solve, and how do you approach difficult problems?
Wow. I could talk for an hour on all the difficult problems we're trying to solve right now. So in the pharmaceutical space in particular, I'll give you an example. So usually in chemical processing, a lot of things are made through what we call continuous manufacturing, where you're constantly feeding raw materials into the process, and then at the end, you're getting the end material. In the pharmaceutical space, because it's so heavily regulated, everything is done in batches, which means you put a little bit of raw material in, it goes through the process, and then at the end, you have some of the material, the end product, whether that's the active pharmaceutical or the end tablets, capsules, all of that, and they come out in batches. And so you make a little bit at a time, which can be slightly inefficient. And so what the pharmaceutical industry is trying to do is they're trying to create more processes that follow that continuous manufacturing flow. But to do that, all of the ingredients that go into medicine have to have really good flow. They have to have slightly different properties than what they currently have. And so, this is a perfect example of something that we're working on in the excipient space is how can we change the morphology or the shape or, of the different powders that are used as excipients? What are different things that we can do to facilitate that process to turn it from batch to continuous. So that's just one example, because there's so many different things around personalized medicine. And I mean, the list goes on and on of a bunch of different things that the pharmaceutical industry is trying to tackle. And as we provide products to the pharmaceutical industry, we look at those trends and we try to help solve those problems for the pharmaceutical industry as well.
Wow, that's really interesting. At some point, I would love to learn more about that because that's really interesting to me in general. So thank you for sharing that with us. And so I will take this time to wrap up our interview again. Thank you so much for joining us. This was definitely a real pleasure. It's always a pleasure talking to you and hearing about so many of the amazing things that you're working on. For our audience, please stay tuned for more information about STEMinista project programming that's coming up. You can follow us on Instagram or Facebook at STEMinista.project and see what's happening. With that said, thank you so much for joining us.